Continuing with Bloomberg NEF's report on New Energy India Outlook, or New Energy Outlook India as they called it. Now let's look at key findings of the net zero scenario. The net zero scenario is based on the global new energy outlook. This normative climate scenario is aligned with the Paris Agreement to keep global warming below 2 degrees C with a 67% probability, as you have to always say. It describes a credible stretch to reach net zero emissions in 2050 with no overshoot or over-reliance on net negative carbon removal technologies post 2050. The NZS uses sector-level carbon constraints for an orderly transition and deploys technologies with credible cost pathways. So net zero can be accomplished by reducing emissions as much as possible and switching to renewables, and then taking out what are called irreducible emissions, because you will still have lots of natural phenomena that will be emitting CO2. So you will need carbon capture technologies to be functioning at scale as well. So you want to minimize that reliance overall. So let's look at some graphs and numbers. India's energy related emissions and net zero carbon budget as of starting in 2000 going out to 2050. India's commitment, remember, is net zero by 2070. So here we are looking at gigaton CO2, not CO2 equivalent. So you have to remember, removing non-CO2 greenhouse gases is going to make this a little bit later. So there are various things here, from industries like steel, aluminum, cement, petrochemicals, and so on, to sectors like road, shipping, aviation, rail, and energy sectors like energy industry, power, and hydrogen, and you have new energy use projected as well. So you can see that the power sector emissions, we're looking at emissions, so reaching peaks of just under 3 gigatons CO2, not CO2 equivalent, and sinking for net zero scenario, and similarly other sectors and so on. Obviously 2020 was when this was pegged, and then you have economic transition scenario, which focuses on cost optimization and not net zero. So you end up going there, where in fact you increase the emissions way above where you are now by about 50% or so, and then you dip back and you don't come to net zero till 2050. So these things have to be kept in mind. Looking at the sectors, a rapidly decarbonized power system becomes the backbone of India's transition to NZS. Higher power demand from increased electrification of net zero scenario, or NZS, means India reaches 3,000 gigawatts of wind and solar by 2050, around 1,300 gigawatts more than in the economic transition scenario. Investments in power system flexibility is also crucial to back up and enable this rapid electrification and decarbonization of the power mix. Some 572 gigawatt of clean dispatchable capacity in the form of batteries, pumped hydro, hydrogen-fired gas plants, and peaker gas plants paired with carbon capture and storage are operational under NZS in 2050, 77 gigawatts more than in the ETS. Okay, you have to make sure you understand dispatchability means when there is a hot day or something happens and suddenly everybody starts demanding energy or power, then you cannot crank up coal plants. You have to still manage this by keeping emissions low. So dispatchability is very important in terms of batteries. Pumped hydro is where you use excess energy to push water up a hill and then flow it downhill when needed to turn the turbines to produce energy, and hydrogen-fired gas plants and gas plants paired with carbon capture and sequestration. So obviously lots of scenarios here. What else do we need? Cumulatively, India reaches 114 gigawatt of coal paired with CCS, 54 gigawatt of gas with CCS, and 97 gigawatt of nuclear capacity. All scenarios. Installed generation capacity and batteries in India by technology and fuel. For the net zero scenario by 2050. So again, looking at the various combinations: coal with CCS, and carbon capture, and gas technology, and did I cut it out? CCGT is combined cycle gas turbine right here. CCS is carbon capture, photovoltaic, so combined cycle gas turbine, which is a way of energy and heat combination, which saves you energy on heating and cooling and so on, producing water vapor, etc. Basically about how you optimize energy production. CCGT with CCS, gas peaker with CCS, and so on, and you have battery storage, pumped hydro, other offshore wind, onshore wind, small scale PV, utility scale PV, geothermal, hydro, bioenergy. So all the combinations are used, and you can see in terms of terawatts, it has to keep going up, and you need to phase out a few things. So you want to phase out coal and coal with CCS, because CCS with coal still can be problematic in terms of what other emissions happen. Okay, so we have to be careful. Reading a bit on fossil fuels associated with this: India's reliance on fossil fuels continues to 2050, but their significance is largely muted in this scenario. The share of abated fossil fuel use rises from 11% in 2030 to nearly all of the fossil fuel use in 2050 in terms of abated fossil fuel, all coal and everything else. Under BNEF's NZS, India could stop imports of all fossil fuels by 2050, which would be great news because India wants energy independence. India consumes around 339 million tons of CO2 in 2050 under NZS, equivalent to 42% of the demand in 2021. That's quite high. India's oil and gas use declined by 83% and 65% from 2021 levels under NZS respectively. Most of the demand destruction of for liquid fuels arises from the complete electrification of the road transport sector. So imagine transport trucks being electrified. Domestic coal availability may not be a significant concern, as the country had more than 360,000 million tons of CO2 coal reserve in March 2022, and cumulative coal use between 2021 and 2015 is only 18,816 million tons under NZS. This is called leaving the assets in the ground. Coal is energy, coal is money, and you have to stop digging it up because it's not good for climate, it's not good for health. India's remaining domestic oil and gas reserves were around 6,000 million tons of oil equivalent in 2018, while total consumption between 2018 and 2050 under the NZS is 5,901 million tons of oil equivalent and 9,257 million tons of oil equivalent under ETS, economic transition scenario. Hence, the NZS pathway appears more in line with India's aspiration to become energy independent by 2047. Should I continue? How long am I here in terms of the podcast? Yeah, let's go one more. Sorry about that, but I have to optimize the length. For fuel use in India, I have to bring up the point again. Fuel use in India by sector net zero scenario in comparison with the ETS, economic transition, where cost optimization is more important. So coal, so here you are looking at different industries including aluminum, aviation, cement, steel, rail, power, petrochemicals, and so on. So coal, ETS continues to burn a lot of coal, but net zero would want it to drop. And gas also, ETS remains high by 2050, but all the combinations have to drop for in terms of billion cubic meters for the various gas use. And oil, of course, also has to drop, even though you see cement production will continue to rise in terms of oil use in a million tons of oil equivalent. So ETS, of course, tends to peak before 2050, but it's too high compared to where you need to be for net zero scenario, right? Road transport electrification under NZS picks up momentum much faster than in ETS, accounts for all of India's emissions abatement in the sector over 2022-2050. It has to reach net zero. The share of EVs in new passenger vehicle sales reaches 100% by 2040, a milestone not achieved in ETS before 2050. India relies heavily on EV adoption in passenger and commercial transport to displace carbon emissions from internal combustion engines. Many details there in terms of already more and more EVs are being bought and being run on the road. The confidence and reduction in range anxiety are good news, but network of charging stations is still bad news. Plus energy to charge them is not so clean, and so on. Okay, so you have to be careful about all those things. Industry, steel sector emissions peak in the early 2030s, reaching 463 million ton CO2 before declining till 2050. Emissions from the cement industry too peak around the same time as at 120 million ton CO2. Coal consumption in steel making declines to 77 million tons, or half of that in 2021. Meanwhile, coal consumption in the cement industry stays similar to ETS, albeit paired with carbon capture and storage technologies, which are still not mature at scale, but much easier to do it at source at a power plant, right? Carbon capture and storage. Our modeling suggests the economic deployment of CCS technologies as a cost-effective way to spur the decarbonization of domestic industries, primarily in the cement industry. CCS gains in importance in the 2030s as tightening sector carbon budgets force hard-to-abate sectors to tackle unabated fossil fuel plants through retrofits or clean greenfield projects. There will be other tools like carbon tax and so on. CCS accounts for 10% of total emissions abated over 2022 to 2050, with applications in industry and the power sector, which are point sources and easier to capture. As the carbon budget bites, the annual rate of emissions captured by CCS grows from very low levels in 2022 to 221 million tons of CO2 in 2030, 465 million tons of CO2 in 2040, and 664 million tons of CO2 in 2050. India's power sector continues to consume coal even in 2050 in the net zero scenario, with 162 million tons of CO2 or 6,000 kilocalories per kilogram consumed, nearly 40% of the amount used in the economic transition scenario. So you reduce the coal use but don't really zero it out. This is due to the presence of CCS paired coal power plants in the power sector under the net zero scenario as well. All this has to be kept in the global context, because if everybody else deploys DAC, direct air capture technologies, like Iceland is doing, let's hope US will also do and Europe will do more, then India's burden may reduce and so on. So global context is always important as to what India should do, including technologies, technology transfers, finance, and so on and so forth. Okay, so let's leave this here, and maybe it'll take at least another one or two podcasts to this is just the summary of the report I'm going through in detail. There are a lot of details in the remaining chapters that you can follow up if you want. Okay, see you in the next podcast.